7200. For a hot air balloon, the way-off procedure is helpful because the A. Pilot can adjust the altimeter to the correct setting. B. Ground crew can assure that downwind obstacles are clear. C. Pilot will learn what the equilibrium conditions are prior to being committed to fly. The correct answer is C. 1. Establishing equilibrium. The way-off procedure involves determining the weight of the balloon and its payload and adjusting the amount of hot air inside the envelope to achieve equilibrium. This allows the pilot to understand the relationship between the weight of the balloon and the amount of lift required to achieve and maintain controlled flight. 2. Safety and performance. By conducting a way-off, the pilot can ensure that the balloon is properly loaded and balanced. It provides an opportunity to assess whether the balloon is capable of generating sufficient lift for safe flight and maneuverability. Understanding the equilibrium conditions before taking off helps in avoiding potential issues during flight, such as inadequate lift or excessive weight. 3. Decision-making and planning. Knowing the equilibrium conditions of the balloon enables the pilot to make informed decisions about the flight, such as selecting the appropriate payload, determining the suitable flight altitude, and planning the duration and range of the flight. It provides essential information for flight planning and ensures that the balloon operates within its safe and efficient performance envelope. 4. Avoiding unfavorable conditions. The way-off procedure allows the pilot to identify any potential issues or limitations with the balloon's weight and lift capabilities before committing to fly. If the equilibrium conditions are not favorable or fall outside the acceptable range, the pilot can make necessary adjustments or decide not to proceed with the flight, ensuring the safety of the operation. Based on this reasoning, option C correctly suggests that the way-off procedure for a hot air balloon is helpful because it allows the pilot to learn what the equilibrium conditions are prior to being committed to fly. This knowledge is crucial for safe and efficient flight planning, decision-making, and ensuring that the balloon operates within its safe performance parameters. 7203. The practice of allowing the ground crew to lift a balloon into the air is A. A safe way to reduce stress on the envelope. B. Unsafe because it can lead to a sudden landing at an inopportune site just after liftoff. C. Considered to be good practice, particularly when obstacles must be cleared shortly after liftoff. The correct answer is B. 1. Unpredictable lifting. Allowing the ground crew to lift a balloon into the air introduces an element of unpredictability. The ground crew may not have the same level of training and experience as the pilot, and their lifting actions may not be coordinated or synchronized with the pilot's control inputs. This can result in an uneven or uncontrolled ascent, leading to an unstable flight situation. 2. Sudden landing. If the ground crew lifts the balloon into the air prematurely or in an uncontrolled manner, it can cause the balloon to lose lift and descend rapidly. This sudden landing can occur at an inopportune site, such as a congested area, a hazardous location, or a place without suitable landing conditions. It poses a safety risk to both the occupants of the balloon and people or property on the ground. 3. Pilot responsibility. The pilot is responsible for the safe operation of the balloon and maintaining control throughout the flight. It is the pilot's role to manage the ascent and ensure that the balloon reaches a safe altitude before releasing the ground crew's hold. Relying on the ground crew to lift the balloon can bypass the pilot's authority and lead to unsafe situations. 4. Proper procedures. Balloon operations typically follow established procedures and protocols, which include pre-flight checks, coordinated ground handling, and controlled ascents. These procedures are designed to ensure safety and reduce the risk of accidents. Allowing the ground crew to lift the balloon into the air deviates from these established practices and can compromise the safety of the operation. Based on this reasoning, option B correctly suggests that allowing the ground crew to lift a balloon into the air is unsafe because it can lead to a sudden landing at an inopportune site just after liftoff. It is essential for the pilot to maintain full control of the balloon's ascent and follow proper procedures to ensure the safety of the flight. 7204. How should a round out from a moderate rate ascent to level flight be made? A. Vent at altitude and add heat upon settling back down to altitude. B. Reduce the amount of heat gradually as the balloon approaches altitude. C. Cool the envelope by venting and add heat just before arriving at the desired altitude. The correct answer is B. 1. Controlled descent. During a moderate rate ascent, the balloon gains altitude by adding heat to the envelope, increasing the temperature of the air inside, and creating lift. To initiate a round-out and transition to level flight, the pilot needs to reduce the rate of ascent and begin descending. 2. Gradual heat reduction. The most effective way to control the rate of descent is by gradually reducing the amount of heat being added to the envelope. By decreasing the heat input, the temperature inside the envelope decreases, which reduces the buoyancy and lift. This gradual reduction in heat allows the balloon to smoothly transition from ascent to descent without a sudden change in altitude or rate of descent. 3. Altitude awareness. The pilot needs to be aware of the desired altitude and monitor the balloon's ascent rate closely. As the balloon approaches the desired altitude, the heat should be reduced gradually to maintain a controlled descent. The rate of heat reduction should be adjusted based on the balloon's performance, atmospheric conditions, and desired rate of descent. 4. Smooth transition. Making a round out from a moderate rate ascent to level flight requires a smooth and controlled transition. Abrupt changes in heat input or rapid descent can result in unstable flight conditions, excessive sink rate, or loss of control. By reducing the heat gradually, the pilot can maintain stability, control, and a comfortable descent for the passengers. Based on this reasoning, option B correctly suggests that the round out from a moderate rate ascent to level flight should be made by reducing the amount of heat gradually as the balloon approaches altitude. This technique ensures a smooth and controlled transition from ascent to descent, allowing the pilot to maintain control of the balloon throughout the maneuver. 7205. All fuel tanks should be fired during pre-flight to determine A. If there are any leaks in the tanks. B. Burner pressure and condition of the valves. C. If the pilot light functions properly on each tank. The correct answer is B. 1. Burner pressure. Firing the fuel tanks allows the pilot to check the burner pressure, which is essential for maintaining proper operation and heat output of the burner. Each fuel tank supplies fuel to the burner, and by firing them, the pilot can ensure that the burner pressure is sufficient for safe and effective operation. 2. Valve condition. Firing the fuel tanks also provides an opportunity to check the condition of the valves. The valves control the flow of fuel from the tanks to the burner, and it's important to ensure that they are functioning correctly. Firing the tanks allows the pilot to observe if the valves open and close smoothly, without any sticking or leakage, which could compromise the fuel supply to the burner. 3. Safety check. Checking the burner pressure and valve condition is crucial for safety. Malfunctioning valves or inadequate burner pressure can lead to improper combustion, uneven heat distribution, or even fuel leaks, which can pose a safety hazard during flight. By conducting this pre-flight check, the pilot can identify any issues with the burner system and address them before takeoff. Based on this reasoning, option B correctly suggests that firing all fuel tanks during pre-flight is done to determine the burner pressure and condition of the valves. This ensures that the burner system is functioning properly and helps maintain safe and efficient operation during the flight. 7206. In a balloon, best fuel economy in level flight can be accomplished by A. Evenly spaced, short blasts of heat. B. Long blasts of heat, spaced as necessary. C. Noting the pyrometer and remaining at a constant temperature. The correct answer is A. 1. Evenly spaced. By using evenly spaced blasts of heat, the pilot can maintain a consistent level of heat input into the envelope. This helps to regulate the temperature inside the envelope and prevent excessive heat loss. Uneven or sporadic blasts of heat can lead to temperature fluctuations and inefficiencies in maintaining level flight. 2. Short blasts. Using short blasts of heat allows for precise control over the heat input. Instead of prolonged heating, which may result in excessive heat and potential fuel wastage, short bursts of heat provide enough energy to maintain the desired altitude and speed. This controlled approach helps optimize fuel consumption and achieve better fuel economy. 3. Regulation of temperature. Balloons often utilize a pyrometer, which measures the temperature inside the envelope. By noting the pyrometer readings and adjusting the heat input accordingly, the pilot can maintain a constant temperature, ensuring efficient fuel utilization. This helps to avoid unnecessary heat loss and excessive fuel consumption. Based on this reasoning, Option A correctly suggests that best fuel economy in level flight can be accomplished by evenly spaced, short blasts of heat. This approach allows for precise control over the heat input, maintains a constant temperature, and optimizes fuel consumption during the flight.